So in today's video, we want to continue looking at examples of, let's try that again. Okay, so in today's video, we want to look at differentiating functions using the chain rule. Again, we're going to look at some more complicated examples. So let's look at differentiating sine of the square root of x. So let's just recall that the derivative of the square root of x is the derivative of x to the 1/2, which is 1 over 2 square root of x. And then by the chain rule, the derivative of sine square root of x is given by differentiating the inside of the function and chucking that out the front. So we'll have 1 over 2 square root of x out the front. We'll then differentiate sine normally, which will give us cosine, but then we leave whatever was in there to begin with. So the derivative of sine square root of x is just 1 over 2 square root of x times cos square root of x. Okay, so if you look at this example, so here we have the logarithm of 3x to the 10 plus cosine x. So we'll differentiate the inside function, in which case we have to differentiate 3x to the 10 times plus cosine x. So the derivative of that is 30x to the 9 minus sine x. And the derivative of a logarithm is 1 over x. So what we'll see is that log e of 3x to the 10 plus cosine of x differentiates to, well, we differentiate the inside, chuck it out the front. So I'll have 30x to the 9 minus sine x times the normal derivative that we get, which is 1 over x, but we leave what's ever in there. So I'll have 3x to the 10 plus cosine of x. And that's the derivative here. I mean, we could also make this one common denominator and get rid of this 1 here, but that's unnecessary. So we'll leave that like this. Okay, let's look at one more example. Here we're going to differentiate e to the x plus tan x. So the derivative of x plus tan x is just 1 plus sec squared x. The derivative of tan can be calculated using the product rule or quotient rule. We've seen that in previous videos. So now the derivative of e to the x plus tan x is just given by 1 plus sec squared x. And then we just leave it alone with the usual, because the derivative of e to the x is e to the x. Okay, that's it for this video. If you liked the video, hit the like button, and if you want to see more of this content, be sure to subscribe. If you have any questions, you can leave them down in the comment section below, and I'll also have notes for this video in the video description.